Dear students, welcomes to all of you in our second lecture of earthquake resistance building and our lecture series of subject design of reinforced concrete structure. I, Professor Prashant Bua, Dr. Subhash Technical Campus, Junagadh. So in previous lecture we will discuss about the earthquake resistance building, how it's affect in our building, how we locate the epicenter, what is the epicenter, what is the focus point, and what is the significant effect on building. Today we will discuss later on our fifth module, what are the philosophy of earthquake resistance design. Before that, since it's cost money to provide the additional earthquake safety in building, so I ask two questions. Should we do away with the design of building for earthquake effects? And second, should we design the building to be earthquake proof whenever there is no damage during the strong but rare earthquake shakings? So clearly, my friends or students, the former approach can be lead a major disaster, and the second approach is too expensive, and hence as a designer or being as a civil engineer, we always design philosophy should be lied somewhere between these two extremes. So neither we design for earthquake proof building or neither we design a weak building that will not resist the earthquake. In between we are get some approach, and that's why this chapter is very important to resisting this earthquake. So starting with the measuring instrument, the instrument that measure the earthquake shaking is called a seismograph, and hence there are the mainly three components. One is sensor, second one is recorder, and third one is timer. These three main components are used to measuring the earthquake. So the principle on which it work is a very simple and reflect the early seismograph we will see in this figure 3. So the pen attach a tip of oscillator sample in and one pendulum of mass used by string from the support. So the marks on a chart paper that is held on a drum rotating at the constant speed. A magnet around the string provide the required damping to control the amplitude and oscillation. The pendulum mass, string and magnet support together consist a sensor. The drum, pen and chart paper consist a recorder, and the motor that rotate the drums consist the speed from the time. So like a very simple arrangement, we have recorded the seismograph. Now we will see the figure of seismograph. So one such instrument is required in each of the two orthogonal horizontal direction, or the courses for measuring the vertical oscillation. Also the string pendulum may be replaced with the spring pendulum, so we can measure in two directional rotation about the drum. So some instrument do not have a timer device. For the example, for drum holding the chart paper does not rotate it, so they have not a sensor like timer or device. Such instrument provide only the maximum extent or scope for the motion during the earthquake. For this reason they are called seismic scopes, and the instrument have annual or time, but today digital instruments are already available in modern computer technology and are more commonly used. So the digital instrument recorder ground motion on the memory of the microprocessor that is built in the instrument. So nowadays we have perfectly find out that direction of earthquake and what is the oscillation or time sensor in a recorded into the drum. So this is the very advantage of this digital technology or instruments. So now we see the figure. This figure is normally used a rational method of noted down the earthquake. So you can see that seismograph is a main component is one support, second one is a chart paper or you can say the drum, one is pendulum which is the heavy mass should be located on below the string, and one pen should be attached of pendulum bob. Now the magnet is rolled to oscillation about the string and pendulum. Now you can see that it should be supported, should be fixed on a ground. When the ground is shaking, the support should be shake, and due to this magnet the pendulum should be rotated, and due to the motor drum should be rotate. So you can see that amplitude of earthquake should be noted as in a red color. So this is the very simple method that will be covered or recorded the magnitude of earthquake, but it's not surely or precisely done the perfect magnitude of earthquake. So that's why the new technique should be developed. Now you can see the horizontal 1000 kg weight charge seismograph in Jaber built in 1909. So you can see that arrangement of digitalization. So instead of string, you can see in the first figure we will put the spring. So what is that use of spring? It should be oscillated in amplitude both the direction, horizontal as well as vertical. You can see that both the arrangement. One for first figure, this one is vertical amplitude measure, and the second one it should be horizontal amplitude should be measured. So this both arrangement done with the help of this spring or digitalization of this technology. So now you can see that there are the two handheld shield and second one is drum shield. So both spring are used, and this is the digital seismograph that should be recorded very precisely our amplitude. Here you can see that there is the sensor recorder provided at the top of our instrument. So they have measured the perfect amplitude of our earthquake. So these are the modern technology, digitalization seismograph are there, and nowadays we have recorded or amplitude the earthquake on the same instrument. Now characteristics of strong ground motion. So the motion of ground can be described in terms of displacement and velocity of acceleration. So variation of the ground acceleration with the time record at the point of ground during the earthquake is called a accelerogram. The nature of accelerogram may vary, will be seen in figure. It depends on the energy release of source. So in our first lecture we will describe the elastic rebound theory, how the rock should be releasing the energy and what should be the fault and rupture should be generated. So same phenomena occurs over there. So this energy release on the source, type of slip and fault rupture in a geological along the travel path, that fault rupture on the earth surface, and it should be a locally affected on soil. So the peak amplitude, or you can say the peak ground acceleration, is denoted as PGA, is a physically intuitive for instant of horizontal PGA value 0.6 g. It means 0.6 times the acceleration due to gravity. It suggests that the moment of ground can cause the maximum horizontal force on rigid structure is equal to 60% of its weight. Now you can see again I repeat the same question. It suggests that the movement of ground can be a maximum horizontal force on rigid structure equal to 60% of its weight. So now here the building weight and their lump mass are very effective during this earthquake phenomena. So in rigid structure all the points in move with the ground by the same amount and hence experience of the same maximum acceleration of PGA. So these are the very important and minor philosophy that should be affected in our building. So it directly connect with our lump mass of building. Now what are the magnitude and intensity? So we know that in previous lecture 1 there are the two measuring scale for the earthquake. One is magnitude and second one is intensity. So now we describe in detail what is the magnitude and intensity. So first terminology. So the point on what the fault where slip start in the focus or hypocenter we see in first lecture. So the point vertically above this on the surface of earth in a epicenter, the depth of focus from epicenter is called focal depth, and the importance parameter of determining this damaging potential of earthquake. So the most of damaging earthquakes have shallow focus and with the focal depth less than 70 km, distance from epicenter at any point of interaction is called epicentral distance. So here you can see that the most of case what should be the effect? It should be a effect of focal depth. How it should be shallow? That building should be cause very severe effect during the earthquake. If the focal depth is very high and if the intensity is very high, then building is not so much damage. But if intensity is low but focal depth is also low, then it should be effect on severe on buildings. So the number of smaller size of earthquake take place before and after big earthquake. We know that aftershock or main shock. Those occurring before the big one are called aftershock, and those one after are called aftershock. So there are the two phenomena. After we realize foreshock, or we can record it aftershock. So as per the guideline of earthquake code, we can feel that aftershock and foreshock. Now you can see the basic terminology. When the rupture of fault start is called focus point. After the focus point vertically we travel to the earth of surface is called focal depth, and that surface touch is called epicenter. Now where the epicenter is located, this one, up to epicenter, when the our building is located, this distance is called epicentral distance. So it's directly proposes these two phenomena. One is focal depth and what should be the epicentral distance. These both are directly proportional to our building hazardous effect during earthquake. So it's very important about focal depth and the epicentral distance. Now we discuss about magnitude. So the magnitude is a quantitative measurement of actual size of earthquake. The Professor Charles Richards has noticed that the some distance of seismograph recorded on earthquake ground or large earthquake have bigger wave amplitude than the smaller earthquake. But for the given earthquake, seismograph at a further distance have a smaller wave amplitude on the location of the close distance. Hence, the promoted him to purpose of now commonly use of magnitude scales and the Richter scales. It is obtained from the seismograph, and the account of the depends of waveform amplitude on epicentral distance, and the scale is also called local magnitude scale. So there are the other magnitude scale like body wave magnitude, surface wave magnitude, wave energy magnitude. There are the different scale also are there, but most commonly we will recorded in a Richter scale, or you can say the magnitude scale. So this numerical magnitude scale have a upper and lower limits. So past earthquake recorded and the signs should be developed during the earthquake resistance building. There are significant scale should be decided in a lower limit and upper limit. So the magnitude of very small earthquake can be 0 or even should be negative also. So an increase of magnitude is denoted by M. In 1 implies to the 10 times higher waveform amplitude and 31 times higher energy release. For instant in energy release in M7.7 earthquake is about 31 times releasing of M6.7 earthquake and about 1000 times of releasing in M5.7 earthquake. So these are the different magnitude we can measure. Is first of all M for magnitude, and the numerical value 7.7. First one is a releasing time and second one is how much times higher energy should be released. So you can see that 31 by 31 times that releasing M5.1 earthquake. So most of the energy release goes into the heat and fracturing the rocks, and only the small fraction of the goes into the seismic wave, and hence travel large distance causes the shaking of ground. So the structure should be damaged due to this releasing the energy. For M6.3 earthquake is equivalent the releasing of 1945 atom bomb drop in Hiroshima. You can see the comparison about atom bomb and what is the intensity of 6.3 earthquake. So is nothing but it likely about the 1945 bomb drop in Hiroshima. So you can visualize the how much energy should be released when the earthquake should be occur just because of 6 So now intensity. So after the explanation of magnitude, you can visualize one scale about magnitude. What should be the energy release as a squad of M6.6. Now what is intensity? So this is the second approach to measuring the earthquake, and it should be a qualitative measure of actual shaking of location during earthquake and is assigned from Roman capital number. Here I highlight that is assigned for Roman capital number. So this scale should be measured in Roman capital number. So there are many intensity scale. Two commonly used are asked in modified Mercury intensity scales and MS scale. So both scale are quite similar and range from starting Roman 1, it means least prescriptive, and the higher range is should be 12, most severe. So that intensity measure in lower limit in Roman 1 and higher limit of Roman 12. How it can be decided? That of course you have a question in your mind. So I earlier said that this lower limit and higher limit should be designed to record the past 100 year of earthquake. What should be that effect on building? So the intensity scale are based on three features of one is shaking, second one is prescription by the peoples of animal, third one is performance of building. So these are the three parameter. At that time we have the intensity scale distributed to any particular earthquake. So the change of natural surrounding give the description of intensity of scale 8 on MS scale. The distribution of intensity at different species during an earthquake is shows the graphically using lines joining place at equal seismic intensity. So now we see this table. Its table should be described in our IS 800 IS code. So intensity 8 distributor and building, you can see that it's very useful table. This should be described about the intensity 8 discussion of building. What are the discussion done building during the 8 class MS scale? So fight and also the person driving on motorcycle are distributed disturbed. Here there is the branch of tree breaks off, even heavy furniture move and partly it should be overturned, hanging lumps and dump in part. Now most of the building of type C suffer the damage of grade 2. So these are the description process of what should be the intensity if scale 8 and what should be the notice near about that epicenter. So likewise, here the two notes are very important. Type A structure, it means rural construction. Type B, ordinary masonry construction, and type C, well built structure. So there are the three category we will divide it into our buildings, or you can say the construction. One is for rural construction, ordinary masonry construction, and well built structure. So the single flow about 5%, many of about 50%, most of about 75%, grade 1 damage, slight damage, grade 2 moderate, grade 3 heavy damage, grade 4 destruction, and grade 5 if the damage is totally destroyed. So these are nothing about the MS scale of 8 class. Next, basic difference about magnitude versus intensity. So here we already described these two phenomena, what is magnitude and what is the intensity. Now we will discuss about basic difference of magnitude versus intensity. So the magnitude of earthquake is a measure of its size. For an instant, one can measure the size of earthquake by the amount of strain energy release and by the fault rupture. This means this magnitude of earthquake is single value, it not should be a change. But on the other hand, intensity of indicator of severely shaking generated at the given location. Clearly, the severity of shaking is much higher near the epicenter. When we travel the further away of epicenter during the same earthquake, the certain magnitude, different location experience different level of intensity. It means the intensity of earthquake are different if we travel the to the epicenter. So it's not a fixed value during the same earthquake, while the magnitude is the same value located in earthquake. So these are the main basic difference between magnitude versus intensity. Now to elaborate this, considering the analogic of electric bulb, we will take one example of electric bulb. The illumination at the location near 100-volt bulb is higher than the farther away from its, while the bulb is releasing 100 watt of energy. The intensity of light or measuring in inmus at the location depend on the voltage, but the bulb and the distance from bulb. Here, the size of bulb is 100 watt is like a magnitude of an earthquake, but the illumination of the location like intensity of shaking at the different location are very different. So we will take one example of 100-watt bulb, so we can visualize or clearly about magnitude and intensity. Now we will take one example of 100-watt bulb. You can see that nearer to the 100-watt bulb, our brightness is clearly 100 volt. If we travel more, it should be converted into 50 volt. If you travel more or far away of 100 volt, but it near about 20. So the 100-watt bulb, you can say that magnitude, it should be a fix. So our bulb is 100-watt magnitude, but intensity, it's traveled near about bulb, it should be varies. So bulb is 100 volt, but intensity should be varies. Near or about to the bulb, intensity should be high. Far away from bulb, intensity should be low. So likewise, when the epicenter is located at near about the epicentral distance, the intensity should be high. When we travel to far away the epicentral, so our intensity is low. It means when the earthquake is occur, and suppose in 2001 one earthquake, it should be epicenter located in Puch. So there are a very severe intensity near about Puch. If we travel to the our Saurashtra region like Rajkot, Junagadh, that intensity should be decreasingly far away to the distance of Bhuj. So these are the main terminology about or difference about magnitude and intensity. Now what are the seismic zones in India? So India lies and northern west end of the Indo-Australia plate, which are encompass the India. So Australia, a major portion of Indian Ocean, other smaller country. The plates is holding against the huge Eurasic plate, will be see in figure. She is going to under Eurasian plate. This process of one tectonic plates getting under the another is called subductor, and she spreaded this plate before they collided. So the part of lithosphere of earth crust is covered by the ocean and the rest of by continuous. So the former and undergo the submersion of this great depth. We will coverage against the another plate, but later is bound the so tends to the remain of close to the surface. So when the coverage large amount of shortening and the thickness of take place like the Himalayas and the Tibets. So our fault line is near about the Indo-Australia plates, and in that plate most of area should be covered under the sea. So it should be again cooling portion and inner crust that will be seen in our first series. It's very high temperature in inner crust. So there are the major cause of effect of this earthquake to this plate tectonics. Now the past earthquake in India, we will see that most of are greater than M8. So it's occur on span 53 years from 1897 to 1950. So the January 2001 Bhuj earthquake, it's the magnitude is M7.7. So it's almost the large. So each this cause disasters but allow us to learn about the earthquake and advanced earthquake engineering. For that instant, 1890 Kutch earthquakes produced the 3-meter high uplift of the ground over the 100 kilometers. Then 1897 Assam earthquake is caused severe damage up to 500 kilometer radius distance. The type of this damage sustainable lead to the improvement, and the intensity scale should be set 1st to 10, and nowadays it should be set 1st to 12. It means the intensity should be increased in past earthquake. So extensive liquefaction of the ground took place over the length of 300 km. Is called slump bed. During the 1934 Bihar Nepal earthquake, which many structure well fault, and it should be a very severe significant effect on building also. So you can see the one table should be show some past earthquake. Here you can notice that what should be the magnitude and what should be the people death and what should be the magnitude intensity. For example, I will took 16 June 1890 Kutch earthquake. Timing is 8. Here you can see that magnitude is 8.3, but intensity is 8. You can see the death of people 1500. Same 1897, the intensity of magnitude of 8.7. Intensity is near about 12, and death of people 1500. Now directly move on the 1990 Chameli earthquake. The magnitude is 6.6, but that intensity is 8. You can see the death of 63 only. Now we will discuss about 2001 earthquake in Puch. Magnitude is 7.7. You can notice down that at 1890 it should be magnitude 8.3. In here 2001 magnitude 7.7, but intensity is 10. It should be a very high intensity. So compared to this intensity, you can see the death of people is roughly 13,805. So I would say that at any earthquake of any magnitude, but here if we conclude the focal depth of peoples and the severe damage on building, so it directly affected intensity, not directly affect the magnitude. So the intensity are very important role play to identify how severe earthquake should be generated in past decades. Now these are the seismic zone on India. So you can see as per the IS 1893, there are in previous IS 1893 there are the 5 zone, but after the 2001 earthquake should be occur, the code should be revised in 2002, and now it should be a 4th earthquake. You can see that. So one seismic zone should be neglected. So starting with the 2nd zone, 3rd, 4th and 5. Now we will see in our Gujarat. So there are the 2 zone you can identify. For Bhuj, it should be a zone 5, and rest of our near about Bhuj, it should be zone 4. If we move about Saurashtra region at the border of our sea coastal, it should be created in zone 3. So same, you can see that in our India there are few are in zone 5. In our Gujarat it should be Bhuj. In upper side you can see that Himachal and Nepal. So these are the some zone mapping done by the IS 1893. So why we seismic zone provided India? So at we design or analyze the building constructed during this any particular city, or you can say the state. So first we located in this state or particular city how its zone should be considered. So suppose we constructed the high rise building in Gujarat. So one building it should be located in Bhuj. So under in zone 5, so we will very precisely design about the earthquake resistance during this high rise building. If we construction in Saurashtra region, so it's under covered by zone 3. So we little but lighter design of earthquake resistance is compared. So likewise, that's why the zone should be divided in all over the India, and it should be divided by IS 1893 part 1 2002. So this all about the design philosophy of earthquake. In next lecture we will see about the what is the design philosophy of earthquake effect on building size and shape of building, how we configure the elevation of building, how we configure the plan of building. So before that you can notice down this today's lecture series about main importance about what is the phenomena of earthquake, what is the focus, what is the focal depth, what is the epicentral distance, what is the difference between magnitude and intensity, and one more, if we little about the difference, query about the difference between magnitude and intensity, so you remind about the example of 100-volt bulb, so you can clearly remember about intensity and magnitude difference. Thank you friends for listening this video. We will see short time our lecture 3 on the same topics, and we will continue our module 5. Thank you friends.